I want you to imagine a scenario. It's a Tuesday morning.
Yeah.
You are sitting at your desk. Maybe you have your coffee in hand.
Naturally.
You lean back in your chair.
Mm-hmm.
You fold your hands in your lap.
Mm-hmm.
You are absolutely not touching the keyboard.
Right.
And you are definitely not touching the mouse.
Kind of hard to work that way.
Exactly. But on your screen, the cursor is moving.
And it's not.
It's not glitching out. It's moving with purpose.
Yeah.
It clicks open a web browser. It navigates to a vendor's website.
It's just by itself?
Completely by itself. It fills out a complex order form, checking boxes, scrolling down to find the submit button.
Wow.
Then it opens a spreadsheet and logs the confirmation number.
That's wild.
It's not a recording. It's not a script you wrote line by line.
No.
It's an AI, literally using the computer interface, just like a human employee would.
It sounds like science fiction. Or maybe a hacker taking over your machine.
It really does.
But this is actually the reality we're looking at today. This is the computer use feature. And it is the headline act for the model we're discussing, Claude Sonnet 4.6.
Welcome to the deep dive. Today, we are not just talking about a chatbot that writes better poetry.
Right.
We're looking at a fundamental shift in mechanics.
We are.
Our source for this is a guide. It's called Mastering Claude 3.5 Sonnet. Though, just to be totally clear for you listening, the text focuses heavily on the upgraded version.
Sonnet 4.6.
Exactly.
It's a fascinating document. It frames this moment not just as an upgrade in IQ.
But as a shift in utility.
Exactly. The premise here is striking. We're looking at a model that claims to be twice as fast as the heavy Opus model.
Which was the previous king of the hill.
Right. Yet it costs half the price.
Half the price.
Half. And if you believe the benchmarks, it's significantly smarter.
That is the holy grail of software, isn't it?
Better, faster, cheaper.
Usually in engineering, you're told to pick two. If it's fast and cheap, it's usually garbage.
Yeah, usually. And that is why we need to unpack this carefully. Claims like that usually come with an asterisk.
So we have a roadmap for today's deep dive.
Let's hear it.
First, we need to understand the brain, specifically the context window and this spooky new ability to control computers.
Then we have to look at the economics. For businesses, that is the bottom line.
Then we will walk through the stress tests, everything from fake operating systems to 3D survival games.
And finally, we'll look at agent mode.
Where the AI takes the wheel on browser automation.
Exactly.
So let's start with the engine. What is going on under the hood here?
What makes Sonnet 4.6 distinct?
Yeah.
Well, the first thing that jumps out is the sheer size of the memory space.
Okay.
This model comes with a 1 million token context window.
1 million. We hear these numbers thrown around a lot. 32K, 128K, now a million.
Right.
But let's ground that. What is a token, basically?
A token is roughly a piece of a word.
So what does a million tokens actually feel like to you as a user?
Think of it this way. It's like giving the AI a very thick book.
Okay.
Or a massive, disorganized folder of code. In previous generations, the AI was like a sieve. It's there. It might read the first few chapters, but by the time you asked a question at chapter 10...
It already forgot the character names from chapter 1.
Exactly. The goldfish memory problem.
You have to keep reminding it. Like, hey, remember that rule I gave you 20 minutes ago?
Precisely. With a 1 million token window, that sieve becomes a vault.
A vault.
It holds that entire thick book in its head at once.
Wow.
It remembers the footnote on page 3 while working on page 500.
That is a huge quality of life improvement.
It holds the state of the conversation perfectly.
But the guide suggests the bigger shift isn't just memory, it's agency.
This computer use capability.
Right. Let's talk about that.
This feels like a real departure. Until now, AI has been a text generator.
You type, it types back.
But Sonnet 4.6 is different. The guide describes this as the ability to handle boring clicking tasks.
Boring clicking tasks.
Yeah. It can read complex spreadsheets, visually scan them, fill out long forms without getting tired.
It acts almost like a real person sitting at the terminal. When you say visually scanned, does it actually see the screen? Or is it looking at the code behind the website?
That is a key distinction. It is actually analyzing screenshots of the interface in real time.
Really?
Yeah. It looks at the buttons, the layout, the text fields, just like your eyes do.
The source mentions it's great at step-by-step development. Is that just about writing code?
It's much broader. The model builds a project, inspects what it made, and then fixes its own errors.
As it goes.
Right. It's recursive. It doesn't just shoot out an answer and hope for the best.
It manages the task from start to finish.
Exactly.
Does this capacity for step-by-step correction fundamentally change how we interact with it?
Yes, it moves from just answering questions to managing entire workflows start to finish.
So we manage workflows now instead of just asking questions.
Exactly. You become the architect. The AI becomes the builder.
But usually, when you get an agent that can replace a junior employee's clicking capability, you expect a premium price tag.
And that is where the market is getting aggressive. The guide breaks down the economics very clearly.
Let's hear the numbers.
For Sonnet 4.6, the input cost is $3 for every 1 million tokens.
Okay.
The output cost is $15 per 1 million tokens.
Contextualize that for me. How does that stack up against the older versions?
It is offering top-level smarts at a middle-level price. It is half the price of the heavy Opus model, but it runs 2 times faster.
And speed matters. Waiting 10 seconds versus 20 seconds is the difference between staying in flow and getting totally distracted.
It really is.
Yeah.
But let's look at the benchmarks, specifically SW Bench.
SW Bench. Explain that in plain English for us.
It is a test checking how well AI fixes code like a software engineer.
Okay. So it's not just writing a simple function.
No, it's much messier.
Yeah.
The test gives the AI a real-world software repository and a bug description.
And it has to fix it.
It has to navigate the files, figure out what's broken, write the fix, and not break anything else.
A test of troubleshooting.
Exactly. In this test, Sonnet 4.6 scores an 80.2%.
That sounds high.
It is very high. It beats its big brother, the Opus 4 model.
So we are seeing an inversion where the cheaper model is actually the more capable one.
Exactly. You no longer pay a premium for intelligence, you pay for efficiency.
So the math is half the price, twice the speed, and better performance.
Impossible to ignore.
Let's move to the visual tests. Numbers are one thing, but seeing what it builds is another.
The guide walks through a few specific test cases.
One of them was building a website for a local business, a locksmith in New York.
This was a test of adherence to constraints.
Right.
The prompt was very specific. A white background, dark blue buttons.
To build trust.
Exactly. And the key detail, an emergency service price of exactly $99.
Sounds simple, but AI loves to hallucinate prices.
Or they get creative and make the button purple.
Right.
But the result was spot on.
Yeah.
Professional fonts, correct layout, exact adherence to the price instruction.
It looks like a human made it.
It did. But then they pushed it harder. They asked it to simulate a macOS computer screen.
Using only web code.
Yes.
Yeah.
Building a system inside a system. The first try was just okay. It was static.
A painting of a computer.
Right. But the tester asked it to improve. The second try was amazing.
What changed?
It added drag-and-drop folders.
Wait, drag and drop?
Yes.
That requires complex logic. Tracking mouse position, updating elements instantly.
It worked. You could change backgrounds. It built a music player with a moving time bar.
I have to admit something here, Beat. I still wrestle with prompt drift myself.
Oh, we all do.
You ask an AI to fix one thing, it breaks 3 others. It forgets the button color.
Yeah.
Hearing it maintains the state of a music player while dragging a folder is so relieving.
It shows real robustness.
It handles layout well, but does it have artistic intuition?
Not quite. Its SVG drawings, like butterflies and robots, are just okay. Opus is still the better artist.
So it's an engineer, not a painter.
Exactly.
Which leads us to the gaming tests. Games are systems. Physics and logic.
This is where it really flexed. First test was a marble board game.
Using mouse movement to tilt a wooden board.
Yes. The marble rolls faster or slower based on tilt. Black holes act as obstacles.
Vector math. Understanding the connection between input and physics.
And it worked instantly. The marble rolled realistically.
But the next test was even bigger. A Minecraft clone.
Voxelcraft. Tested using kilo code.
Huge prompt, I imagine.
Massive. Health bars, food bars. Breaking and placing blocks.
And deep caves under the ground.
Yes. It included a proper start menu, which is rare, and it generated those deep caves.
Whoa! 2-sec silence. Think about that. Generating deep caves under the ground.
It's crazy.
The AI built a hidden part of the world just because the prompt asked for it, simulating depth we can't initially see.
It really is a moment of wonder.
Did the browser actually handle a full 3D survival game written by AI?
Mostly yes, though the graphics were heavy. The logic held up, even if the browser struggled.
So the underlying system worked flawlessly, even if rendering lagged. We're going to take a quick break for our sponsors, and when we come back, we'll talk about agent mode.
Sounds good.
And we're back. Let's look at the agent workflow, the big data task.
This is about automation, treating the AI as an autonomous agent.
The prompt was a long chain of commands. Create a folder, write a Python script, open a browser.
Search Google for news, save to file, build a dashboard.
That is where things usually break down. The AI forgets step 3.
But this time, it utilized Selenium.
Define Selenium for us.
It's browser automation software, code that clicks buttons on websites.
Usually very finicky.
Very. But the AI wrote the script and executed it.
Wait, it ran the code?
Yes. The computer physically opened the browser by itself, typed in the search bar, found top links, populated the dashboard.
Is the main advantage here capability, or is it reliability?
Reliability. Unlike others that get lazy, this model finishes long lists of steps without stopping.
It doesn't get lazy and quit halfway.
Exactly. It follows through.
If someone listening wants to actually use this, how do they get access?
The official chat is free, but has limited messages.
The dreaded rate limit.
Yeah. There's the API, which is pay as you go.
$3 in, $15 out.
Right. Then there's LMSYS for free side-by-side testing.
And Kilo Code.
Open source platform offering $25 in free credits. Great for testing.
Okay, what is the tactical advice for prompting this thing?
3 tips. First, be specific.
Give us an example.
Don't just say write an ad. The guide uses the AI Fire newsletter.
Okay.
Specify the hook, the audience busy office workers, and the promise to save 5 hours a week.
Give it constraints.
Second tip, iterate. Build in small pieces.
Like stacking Lego blocks of beta. Login screen first, then dashboard.
It stops the AI from getting confused.
And third tip.
Feed the memory. Use that 1 million token window. Paste in whole documents.
Don't be shy.
Exactly.
Let's recap the big idea here. We are seeing a shift toward high intelligence, low price.
Yes.
It excels at doing coding, clicking, automating.
Rather than just knowing facts.
It lacks artistic flair for SVGs, but makes up for it with strict adherence to rules and massive memory.
It's a highly skilled engineer.
So here's my challenge to you listening. Try the Marble Game prompt, or use Kilo Code credits to build a small tool.
The source mentions knowing how to use these tools reduces work stress.
We are moving away from reading every line of code to orchestrating the system.
It's a totally different kind of work.
Focus on the what and why. Let the AI handle the how.
Exactly.
Thanks for diving in with us.
Always a pleasure.
See you in the next deep dive.